Hello friends, today I'm going to solve LeetCode problem number 1339, maximum product of splitted binary tree. In this problem, we are given the root of a binary tree and we need to find the maximum product of the sum of the two subtrees. So let's see how we could solve this problem. But before that, let's see what are the subtrees that we could form. So here in this example, well, 4 is a subtree and the complementary subtree here is this. So as we have been said in this like explanation that the product should be the sum of the two subtrees, and those two subtrees are actually formed by splitting the binary tree into two. So we are only splitting the binary tree into two so that no node is left uh, orphan. So this is our subtree 1, this is our subtree 2 in this case. In the next case, we could also form subtrees such that this is our subtree and then this becomes our another subtree. Now let's look another case. If we choose to pick this as our subtree, then another subtree which could form is this. But here 5 is abandoned because 5 is connected through 2. So since we are not considering 5 in our subtree, in this subtree here, so 5 becomes abandoned and we don't want this to occur. So basically we are trying to look for subtrees such that it is a full tree so far. So this is one subtree we could form, and another subtree we could form is this, where then the complementary subtree for this one would be the remaining nodes. And then again another subtree that we could form is this subtree. If we form this subtree, then this would be is complementary subtree, and so on. So I guess that you get the idea now. Now once we form a subtree, we need to form it in such a way such that the sum of the first subtree times the sum of the next subtree gives us the maximum value. So the product of the sum of the two subtrees is maximum. So before that, we need to find the sum of each of the subtrees, right? So how could we find the sum? Because we actually need to find the sum of each subtree and find the one which is the maximum. So how could we find the sum of each subtree? Basically we only need to find the sum of S1s, and then for S2 what we are gonna do is we are gonna subtract it from the total sum. So we are gonna subtract S1 from the total sum, which will give us S2. So in this example here, if this is S1, then this is S2, and we know S1 and S2, it's forming this complete binary tree, right? And the sum of this whole binary tree is TS. So S1 plus S2 gives us TS. So to find S2, all we need is S1 and TS. So that is what we are gonna do here. We are gonna find only the sum of each of the subtrees S1, and then the complement we will find from this formula here. So how are we gonna find the sum? Let's suppose we have this subtree. To find the sum of this subtree, we need the sum from its left branch and sum from its right branch. So sum from its left branch, suppose it's LL, sum from its right branch is SR. So we are adding this to sum to the value of this node. So to get the sum S1, we need the left sum, we need the right sum, which are the sum from the left branch, sum from the right branch, and the value of the node. So that will give us the sum of this subtree. Once we have the sum of this subtree, the complementary, as I already told you, which is this subtree, we could find it through this formula here. So what we do is we find the sum of this subtree here. Now we go towards the right of this and we find the sum of this subtree. Basically we are starting from the root node, so to find the sum of this whole subtree we need the sum of this subtree, and then the sum of this subtree is the value of this node itself. So the value of this node is equals to 6, so the sum here, total sum, is 6 plus 3, which is 9. So we get a 9 here, and here we get an 11. So now to find the sum of this whole subtree, okay, let me just clear things up. Alright, so to find the sum of this whole subtree, we need the sum from its left branch, which is this one, and from its right branch, which is this one. So we know the sum of its left branch is S1, which we know is 11, and the sum here, which is 9. Now we pass these two sum, the left sum and the right sum, and we add the value of the node, which is equals to 1. So the total sum here is 21. So this total sum, once we get this total sum, then what we are going to do is we are going to find the complementary of each of those and then compare the product of the S1 with S2, S1 S2 with the product of other values, other subtrees. So I guess you get the idea so far. Now let's try to code it, and I will explain it while I am coding as well, so that you understand. So to store the result of each of the subtree, sum from each of the subtree, I will use this array. And also we are said that the answer may be very large, so we need to use this modulo 10 to the power 9 plus 7, so that the answer is not so large. So method power of 10 comma 9 plus 7. Now let's create our DFS function. We are gonna pass our node here, and if the node is a null node, then we are just gonna return a 0. And I'm also using this left and not that right. So this says that we have reached our leaf node. So if that is the case, then we return the value of our leaf node. So here 4 is a leaf node. So once I have reached 4, I do not need to go any further because there are no nodes at all, right? So that is when I return the value of 4 to its calling function. So that value will be the sum of the left branch for this calling function. So once I have done that, if it is neither the root node, the leaf node, nor the node is a null, that is when we perform our recursive call to the left and to the right. So let sum left. So from our recursive call, we are going to receive the sum of the left. So we go to the left tree, and then we also go to our right subtree. So, and we get the values for our left and right subtree, and then we push those values to our result. So once we have pushed those values, what we do is now we return the value of left summed with the right plus the value of the node, which is in case of this subtree 2, 4, 5, the sum from left is 4, the sum from right is 5, and we push this to sum 4 and 5 to our array, and then what we do is we return the sum of left 4 plus 5 plus 2, which is the sum of this whole subtree, to its calling function, which is 1, which is the calling function 1 dot left. So so that whole sum will actually be the left sum of this root node 1, and similar is the case with the right node. So once we have done this, let total sum equals to df as root. So the total sum will be the sum of left plus right plus the root node of this tree 1. So that will give us our total sum, and once we have received our total sum, now we need to find the maximum product, right? So for that we need to iterate over each of the element of the result, and we find this product, like current product is equals to element, the current element times the total sum minus the current element, which gives the sum of its complementary subtree, and then we check the maximum, the product. Okay, we need one more variable, the max variable, let's set it to 0. So now max equals to max of either the maximum value or the current product. So we take the maximum of the max product, the maximum value we already have, or the current product. So if the current product is the maximum, then the maximum value becomes a current, and so on, and we finally return our max value. And we need to take the modulo of the max value so that it's not greater than, it's not a large number, too large number. Let's run our code. Great, let's submit it. Awesome. So the time complexity here would be a linear time complexity, because we are performing a DFS operator where we are traversing through all the nodes, right? All the left nodes, all the right nodes. So basically we are traversing each of the node until we reach the leaf, and so the time complexity is O of n, and the space complexity is also O of n, because we are using an array to store our sum, right? So that's it.